Alright, so today let's talk about exact versus rounded numbers. And I bring this up now because it will begin coming up on the assignments that you may do a problem, whatever the problem is, and it may call for one type of answer or the other, or maybe both, okay? So before I talk about the way you might see it in your problems, let's just talk about what is an exact number versus what's a rounded number. And I give this example right here. Take the square root of 2, okay? And I've written down this statement that says the square root of 2 is approximately equal to 1.41, okay? Notice there that I did not write an equal sign. I wrote our symbol for approximation, okay? Now, in terms of our vocabulary, this is what you need to know. The square root of 2 is an exact number, okay? In 1.41, it's rounded to 2 decimal places. They're not equal to each other, okay? They're close, but they're not equal. So here's where the link between these two comes up, is that maybe we're using our calculator and we come across the number root 2 and we try to figure out what that is, and it might give us something like this, 1.414213. You see all those digits right there in that decimal? I've written down 2 of them. I've rounded it to 2 decimal places, okay? All right, so root 2 is the exact number. 1.41 is what that number is if you round it to 2 decimal places. They're not equal, but they're close, all right? Okay. Now, that's it. I could end the video right there just to point out the difference between an exact versus a rounded number. And when you're in math class doing your assignments, it will come down to just following the instructions. If the problem says give the exact answer, give something like square root of 2 as your answer. If it says give the answer rounded to so many decimal places, well, then you round it. But the instructions will specify the way that we want it. Now, sometimes people are tempted to, write down like that whole thing. Like, see right here, I wrote down every single digit in that number on my calculator screen, but they're still not equal. You can't write down all the digits to root 2. It's not possible. So even if you tried to write down every single digit on your screen, we would still only say that these two things were approximate. They're not perfectly equal. They're really close to each other, though. Okay? All right. Now, I thought from here I'd elaborate a little bit about the vocabulary and show you an example. Okay? So, root 2, the reason why I can't actually write down all those digits and say that it's equal to root 2 is that root 2 is what is called an irrational number. And all that means for us is that the decimal expansion of root 2 continues forever with no predictable pattern. Well, think about it like this. If the decimal expansion of root 2 continues forever, that means that I can't write the entire number down, okay? So that's kind of the long story behind why no matter how many of these digits you write down, that decimal will never be perfectly equal to this number over here. Okay? All right, so you get the difference. The exact number versus that number rounded to so many decimal places. Let's try an example of the way that you might see it if you're doing problems. So here's an example that I think is fairly straightforward, but still it's something kind of like what you might see in the homework. So let's say we want to solve that, and part 1, I'll give you the exact answer. And part 2, I'll round the answer to 3 decimal places. Okay? All right. Well, how do you solve this problem? Well, for every type of problem, there's a certain technique. And part of you learning to do some math is learning to recognize the problem and remember the right technique to use. Okay? Okay, so this is the kind of problem that we solve by the quadratic formula. And I have made another video about that, all right? So if that's something that just sounds completely unfamiliar to you, you can look at the video on the quadratic formula, but here's how that works, okay? The answers to this equation are built this way. We use a formula. We do the opposite of this number, that's a 1, plus or minus root. We take this number squared, that would be 1 squared, minus 4 times that number, which is also a 1, times this number, which is a negative 1. All right. So, divided by 2 times that number. Now, I'm not explaining this the way I would if I was showing somebody for the first time how to use the quadratic formula, but that's what it comes down to, okay? If you need to review it, go look at the video to review it. So, okay, what's this? What's this number? Negative 1 plus or minus, what's that number in there? 1, and then negative 4 times 1 times negative 1. So that's 1, and that's going to be a positive 4. Or, sorry, positive 5. Okay, over 2. 2 times 1 is 2. So then that does not reduce any further. There's your answers, okay? If I wanted to give my exact answers as a list or something, I would say first answer, negative 1 plus root 5 over 2. And then my second answer, negative 1 minus root 5 over 2. Okay, and there they are. Those are the exact answers. They're perfect, all right? Now, take my exact answer, round to 3 decimal places. Well, that's just going to involve using the calculator and getting it to 3 decimal places. So let me show you how we can do that. Okay, there's my exact answer. That's perfectly correct, all right? But I'll just do like this. In my calculator, here's how I'll do it. I'll do negative 1 plus root 5, okay? And then I'll take that number, and if I just hit divide, it thinks I want to divide negative 1 plus root 5 divided by 2. And I get this number, 0.618. And if I round to 3 decimal places, there's the third digit, 0.618. So my rounded answers are 0.168. Okay? And if you did negative 1 minus root 5 over 2, you would get negative 1.618. Okay? So I got 2 answers, but there they are rounded. Okay? So you get the idea. This is exact. This is perfect. These are rounded. They're only approximate. Now, the more decimal places I round to, the more accurate that number is going to be. But it's still rounded and it's not perfect. But in practice, we usually have to round numbers, so that's why we do it. Okay? All right. Now, so in the videos, here's what I've done. I've told you what an exact number is. I've told you what it means to round the numbers. I told you that when you take an exact versus a rounded number, they're not going to be perfectly equal. And then I showed you a problem where I gave you the answer in each form. Now let's talk about one more thing real quick. If we round our answer, can we still check it? You know, occasionally in the videos, I'll recommend, since you're learning math, it's good to check your answer to enforce what you're learning. Okay? So here's what we just did. There was my equation, and those were the answers I got when I rounded it. Okay? So what does it mean if that's an answer? If I'm telling you that this is an answer, or this is an answer, what does that actually mean is going to happen? All right? It means if I take this number and I put it in for the x, that will become a true statement. That's what it means. Okay? So if I take 0.618 and I square it plus 0.618 minus 1, that should be equal to 0 if that is correct. Okay? So say I plug that all in right there, and then I get my calculator and I do 0.618 squared plus, and I do all that, I actually don't get 0. Okay? That does not end up being 0. If this was right, this would say 0 equals 0. It would be true. Same thing with negative 0.618. If I plug that in and do all the math, it should say 0 equals 0. So what's the deal? Well, remember, these answers don't check perfectly because they weren't exactly correct to begin with. That's what happens when you round numbers. They're not going to be perfect anymore. They're not going to be exactly correct anymore. Okay? So, yes, if you take a problem and you work it and you round your answer into some decimal and then you try to check it, it probably won't check perfectly. All right? As long as you're aware of that, that's okay. These are still right. It's just that they're rounded and so they're not perfect. Okay? Sometimes we have to, relax our desire to have things perfect. This happens with measurement. When you measure something like in science class and you record your data, often you can't get the measurements perfect. They're not going to be 100% accurate. There's something called measurement error. Rounding your numbers in math is kind of like that.